Hello, my name is Florian Jung and I'm a researcher in the Visual Healthcare Technologies department at Fraunhofer IGD in Darmstadt. We are part of the OraMod consortium. In this short video I will give you some insight into the OraMod project and the image analysis software which we have developed within this project. The OraMod project is an FP7 funded project by the European Commission, and the goal of the OraMod project is the creation and training of a predictive model for oral cancer reoccurrence. But before I start off with some more details about the OraMod project, I want to give you some small motivation. Head and neck cancer is the 7th most common cancer worldwide. It has a significant low survival rate and the reoccurrence chance is quite high. The search for reoccurrence indicators is still ongoing. Some indicators like drinking and smoking are already known, but besides these indicators, the reoccurrence of the tumor seems quite random. So, the goal of the OraMod project is a creation of a predictive model which helps to predict if the cancer will reoccur within a specific patient. Okay, let's have a closer look at the OraMod prediction model. The OraMod prediction model is a statistical model based on patient biomarkers. We extract these biomarkers from 3 different fields. First, we have the metadata. This is, for example, the age, the gender, and smoking habits of a patient. We have the gene biomarkers, and we have the image biomarkers, which we all extract from one patient dataset. To train the whole model, we have a pool of 150 patient datasets, which we use to train the OraMod prediction model. Once we have trained the OraMod prediction model, we can use it for new patients to give a probability what the chance is that the cancer will reoccur. Our part in the OraMod project is the development of an image analysis software which is used for the feature extraction from medical image data. On this slide you can see a small overview how the image analysis workflow takes place in clinical practice. A radiologist requests the image data from a clinical PACS server. These image data are then transferred to his desktop workstation. On his workstation, he does the whole feature extraction process from the medical image data. And finally, once he has extracted all relevant features, these features are then sent to the OraMod system, where they can then be further processed. And now I will give you a short demonstration of the image analysis software which we have developed at Fraunhofer IGD. The feature extraction process is divided into 3 steps. First, the radiologist has to select the medical image data. Then he has to do the segmentation of the tumor. And finally, he has to segment relevant lymph nodes. I have already selected the image data in this case, so we can directly go to step 2, the analysis of the tumors. First, the segmentation of the tumor has to be done. This is an extremely time-consuming process. Therefore, we have developed an automatic algorithm within the OraMod project to fasten up this step. Here we can see the primary tumor of the patient. And to do the segmentation, the radiologist only has to click into the middle of the tumor, and then some sophisticated algorithms do the automatic segmentation of the tumor. This usually takes several seconds, and now we already see the final segmentation of the tumor. In case the radiologist is not completely satisfied with the result of segmentation, we have implemented some additional tools to manually modify the result. For example, if he wants to subtract something from a segmentation he does not like, he can do this using these manual tools. Once he confirms the tumor, the major and the minor axis and the volume of the tumor are calculated. Next, the radiologist has to select some additional features. First, the principal site of the tumor. Then, if any extension sites are present. And the site of the tumor, if a spread across midline has taken place, and if the tumor contains a necrosis. He can manually input the T-staging of the tumor as well, but I will leave this point out right now because we have developed an automatic algorithm to determine the T-staging of the tumor fully automatically. Finally, the radiologist has to decide if the tumor has already invaded any crucial areas in the body. In this case, no invasion has taken place yet, so we can mark all as absent. In case an invasion like a tongue muscle invasion would have taken place, we can directly show you that now the T-staging of the tumor has changed and it has been upstaged to a T4 tumor. This is this fully automatic T-staging determination which we have included in our software. Once the processing of the tumor is finished, the radiologist can move on to the analysis of the lymph nodes. The segmentation of the lymph nodes is similar time consuming as the segmentation of a tumor, therefore similar to the segmentation algorithm of the tumor, we have implemented an automatic segmentation of lymph nodes in our software as well. To do the segmentation of the lymph nodes, the radiologist just has to roughly segment the lymph node in one slice. And once he has done this, he can start the automatic segmentation of the lymph node and quickly gets the final result of the segmented lymph node. After he has confirmed the segmentation of the lymph node, the software again calculates the major and the minor axis and the volume of the lymph node. Additionally, the radiologist selects the site of the lymph node as well as the site within the patient dataset and the site relative to the tumor. And if a cluster is present. And finally, if the lymph node has invaded any structures. Once he is finished with the processing of the lymph node, he can save the patient dataset or he can take a screenshot which can be later displayed within the OraMod system. And once he is done with the whole feature extraction process, he can send the extracted features and the screenshot to the OraMod system, where then other clinicians can have a look at this data. This concludes our short demonstration of the OraMod project and the image analysis software. Thank you for your time.